Well, we're going to start off our discussion of different types of energy with kinetic energy. Now, kinetic energy is the energy of motion. So just the fact that something is moving means that it has energy inherent within it. Energy depends on kinetic energy at least, depends on two specific things. It depends on an object's mass and it depends on its velocity. And this discussion may sound kind of similar to when we were talking about Newton's second law. If you picture a football player, and I'm thinking of American football here, I'm not thinking about soccer, I'm thinking about American football. And if you have guys on the line and you have a really, really big, huge, bulking football player, and he's trying to stop some of the other guys from running in and sacking the quarterback, then you want the really big guys on the line because they're going to be able to block the runner the most. On the other hand, if you're going to try to have somebody charge through that line to get to the quarterback and get him sacked so he can't pass the ball, you want a really, really big guy to do it, right? And so if you see this big guy charging at you, at least my reaction is going to be, I'm going to get out of the way. I don't want him to hit me because he's got a lot of energy, a lot of kinetic energy specifically once he starts moving. Now, he's going to have energy. If he would just be walking down the street and he'd run into me, it's not going to feel good just because he's so big. But if he's charging at me at full speed, that's going to hurt even worse. And so it's a matter of the fact that not only is this big guy big, but if he's moving very fast, he's going to have a lot more energy as well. And so in order to calculate the amount of kinetic energy an object has, or a person has for that matter, kinetic energy is equal to 1/2 of the mass times the velocity squared. Now, hopefully you remember what it means to square something. So if I have the number 2 and I square it, what that means is I'm taking 2 times 2, which will give me 4. If I have the number 3 and I square it, that's 3 times 3, which is the same as 9. So if you recall, squaring just means that you're going to take a number and you're going to multiply it times itself. Okay, so I'm going to take whatever the velocity is and I'm going to multiply it times itself. The other thing to remember is if you're using a calculator for this, 1/2 is the same as 0.5. So when you type it into your calculator, you probably want to type in 0.5 when you're doing these problems. All right, so which one is going to play a bigger role in an object's kinetic energy? Is it going to be its mass or is it going to be its velocity? Well, let's do a couple of comparisons here and see if we can figure that out. Let's check with the mass first. Let's say that I have a 2-kilogram ball that's moving at 2 meters per second. And let's compare that with a 4-kilogram ball that's also moving at 2 meters per second. So you can see that my velocities are the same in both cases, but the difference between these two is that this ball has twice the mass that this one does. So let's calculate the kinetic energy and let's see where we are. So the kinetic energy of this one is going to be 1/2 times the mass, which is 2 kilograms, times the velocity, which is 2 meters per second, and I'm going to square that whole thing. Okay, so if you type this into your calculator, you're going to type 0.5, which is 1/2, 0.5 times 2 times, and then you have to square this, so it's 2 times 2. So it's 0.5 times 2 times 2 times 2. Okay, so when I do that, I'm going to end up with 4 joules for this particular ball. Okay, now let's check the 4-kilogram ball. If I calculate the kinetic energy for this one, I'm going to have 1/2 times the mass of 4 kilograms times 2 meters per second, and we're going to square that. And so when I do that, I have 1/2 of 4, which is 2, times 2 times 2, which is going to give me 8 joules. Okay, so you can see that here, if I've doubled my mass, I'm also going to double the amount of kinetic energy that I have, okay? So 2 times the mass will lead to 2 times the kinetic energy, okay? That seems like a logical jump, right? If something is twice as big, it's going to be able to do twice as much work if it runs into something, okay? Now, let's turn around and let's compare velocity now. Let's say that I have 2 balls and they're both 2 kilograms. So here on this side, my mass is going to be the same on both of them. But this ball is moving at 2 meters per second, while this ball is moving at 4 meters per second, okay? So the velocity, the mass is the same, but this velocity is twice as fast as this one is. So let's check kinetic energy on these two, and let's see where we end up. So once again, kinetic energy equals 1/2 times the mass times the velocity squared. And so if I do that, in fact, that's the same problem that we just did over here, 1/2 times 2 meters per second squared. So I know that the kinetic energy of this ball is going to be 4 joules, okay? So let's do the same thing with this ball now. Here, kinetic energy equals 1/2 times, I have a 2 kilogram ball, and it's moving at 4 meters per second, and I have to square that. So here, on this one, my kinetic energy, if I square 4 meters per second, that's going to give me 4 times 4 is 16. 16 times 2 is 32, and then if I take half of that, that is going to be 16 joules. And so you can see that even though, in this case, even though I have doubled my velocity, my energy, kinetic energy, has actually gone up by a factor of 4. And so the difference when I double my velocity makes a much larger difference in my kinetic energy than it did when I just doubled my mass. So here, 2 times the velocity leads to a difference in 4 times the kinetic energy, okay? So as you can see, if you are trying to increase the amount of kinetic energy something has, the velocity plays a much larger factor than the mass does, because when you're calculating it, you have to square that velocity in order for that to happen. Okay, so you will get some practice today calculating kinetic energy and seeing how that works.